Hello, my name is Keenan Fennessy, and I'll be talking about antioxidants. Antioxidants are substances used to preserve food by delaying deterioration, discoloration, and rancidity due to the oxidation acting as free radical scavengers, donating electrons of hydrogen, and they neutralize free radicals. To act as an antioxidant, molecules must react with free radicals more rapidly than free radicals reacting with lipids. The products with the free radicals must not be pro-oxidative, which means the molecule must be lipid soluble. There are two types of antioxidants, primary and secondary. Primary donates an electron or hydrogen to a free radical to stabilize it, and it becomes a compound that is more stable than the original radical. Examples of this is ascorbic acid. They also terminate free radical chains and function as electron and hydrogen donors. They have phenolic antioxidants like butylated hydroxyanisole, which is BHA, and then you also have, like I said, your ascorbic acid and ascorbyl palmitate. There's also carotenoids, which scavenge oxygen and radicals. They have chelating agents and sequestrants that remove metallic ions, especially copper and iron, that are powerful pro-oxidants. They have enzymatic antioxidants that can remove and dissolve oxygen, or you could say glucose oxidase and catalase. They have natural antioxidants that present in many spices and herbs that we use in the kitchen, like rosemary and sage, that are the most potent antioxidant spices. Then we have secondary antioxidants. They remove the compound acting as the oxidative. Examples of this would be that they absorb UV light, they chelate transition metals, and inhibit enzymes involved in the formation of reactive oxygen species. And then the chelator examples would be like EDTA and polycarboxyl acids. Butylated hydroxyanisole, which is BHA, is a white waxy solid that survives processing and forms radicals more readily than BHT, which is butylated hydroxytoluene. And by butylated hydroxytoluene is a white crystalline solid that is more stable than BHA. But they both are used for lard shortening, vegetable oils and cereals, package liners, and animal feeds. And then you have tertiary butylated hydroxyquinone, which is a white to tan colored powder that functions best in frying foods or baking, that's more readily used in baking applications. And it provides protection for fried foods. Then you have ascorbic acid that acts as a primary and secondary antioxidant. For primary antioxidants, they donate hydrogen atoms. For secondary, they scavenge radicals, converting hydrogen peroxides into stable products. You have carotenoids, which also act as primary and secondary antioxidants. For primary, they trap free radicals, and for secondary, they grab onto single oxygen ions. Then you have antioxidants that affect the food processing, which will be called Maillard reactions or Browning reaction between proteins and reducing sugars that could produce antioxidant compounds. Sequestering agents bind to metals and prevent them from catalyzing. We have factors that affect the efficiency of antioxidants. You have solubility, oxidation reduction potential, activation energy of antioxidants, and the stability to pH. Then you have the choice in which it depends on, which is the stability of food processing conditions, again, pH, temperature, light, air, etc. You have effectiveness and the incorporation of foods, the solubility of foods. Then there's the application of foods, which kind of correlates with the direct addition to oil, spraying oil on foods, dipping food into antioxidant solutions, and the packaging material that the food comes in. I hope you all learned something about antioxidants today. Go out there and get you some blueberries, and thank you.